Greetings and welcome everyone. Today I am excited to present my Energy Performance Certificate dashboard for Manchester in United Kingdom. This interactive dashboard provides comprehensive insight into the energy performance of domestic properties in the Manchester region. The data used in this dashboard is from the UK government's Open Energy Performance Certificate dataset, which provides official information on domestic energy efficiency assessments and recommendations. Before we dive in, let me give some context about the shape of the dataset. The dataset consists of two main CSV files, certificates and recommendations. The certificate dataset contains approximately 325,000 rows and 93 columns, covering property details, inspection dates, energy rating, CO2 emissions, fault types and estimated cost. The recommendation dataset contains approximately 1 million rows and 7 columns. Both datasets are structured in a tabular format and they linked using a common unique identifier which allows certificates to be connected to their corresponding recommendations. To prepare the data for analysis, both CSV files were imported into Microsoft SQL Server. I will briefly explain how I prepared this data. First, I verified the data loaded correctly by counting records in both tables. Then I identified some data quality issues. The original dataset had many columns that were not needed for our analysis. Things like address columns, country, and various duplicate columns. I physically dropped these columns from the table to improve performance of the dataset. I count null values in every column, which helps me to understand where the data were missing. There are no duplicates in this dataset. It's guaranteed by authors. I found many columns with invalid values like no data, unknown, or NA values. I created a stored procedure called clean invalid strings that automatically converts all these invalid entries to proper null values across all text columns. This ensures our analysis only includes genuine data. Then I created different specific views instead of one massive table with over 90 columns, each focusing on a specific aspect like property information, energy ratings, carbon emissions, dashboard summary, etc. For time-based analysis, I created two date dimension views, one for inspection dates and one for lodgement dates, using common table expressions that helps to generate the difference between inspection date and the lodgement date. I added useful calculated fields like efficiency gap, the difference between current and potential efficiency, total cost, combining heating, lighting and hot water cost, and annual savings. Each view has a specific purpose on dashboard, making the performance much faster and much better. Now let me show you how this already clean, organized and prepared data comes to the Power BI dashboard. I connected Power BI to SQL using this Get Data option. After that, I import all the views from the SQL Server. Then I importing all the views from the SQL Server. I created a relationship in Power BI, connecting the relevant fields between the views to ensure the data is properly linked for analysis. I have created several DAX measures to summarize the data in the dashboard. Certificates issued per year, total recommendations, and overall certificate counts. This is our landing page, which provides an introduction to the dashboard. Energy Performance Certificates, or EPCs, are required whenever a building is constructed, sold, or rented. They rate properties from A to G, helping property owners understand their energy cost and environmental impact. A means highly efficient and G means least efficient. The dataset covers certificate issued from 2006 to 2025 and the last update on 27th November on 2025. Basically, this dashboard provides insights across main two key topics. Number 1. Data on the number and proportion of EPCs lodged by the region and the property type. Overview, cost, property characteristics. Number 2. Data on the number and proportion of EPCs within each energy efficiency band. Energy efficiency recommendations. We can see the dashboard coverage and energy rating scales. There are also useful links to EPC statistics, technical notes, and the gov.uk website for more information. Now let's look at the overview page, which gives us high-level summary of the entire dataset. At the top, we have 4 key metrics. 325.69k total certificate. These are the total number of EPCs issued in Manchester. 1048.58k total recommendations. That is the number of improvement suggestions. Average CO2 emission is 3.18 in tons per year. Average environmental impact score is 65.57. On the left, there's a pie chart showing the average cost distribution. You can see that heating cost account for 71% shows 570 pounds, lighting cost are 9% shows 74 pounds, and hot water cost are 20% shows 160 pounds. The middle shows total certificate by main fuel type. According to these numbers, we can demonstrate that most of the Manchester properties are used main gas as a central heating. On the right, we have count of certificate by built form. Mid-terrace properties lead with 126,926 certificate, followed by the semi-detached with around 96,785 certificate. In-terrace properties with about 69,114 certificate, and so on. This figure shows that terrace and semi-detached homes are the majority of the Manchester's house stock composition. The table at the bottom summarizes energy performance by property type. It has 5 columns shows the total number of certificate, the average current energy efficiency, the average potential energy efficiency, and the efficiency gap. Houses have the higher number of certificate, while flats show higher average current energy efficiency. The efficiency gap highlights how much each property type could improve through energy efficiency measures. Moving to the property characteristic page, this section focuses on the physical attributes of Manchester properties. At the top left, I include cards that shows the average floor height 2.51 meters, average floor area 75.91 square meters. Also, we can see the buttons to filter by property types as your preference. The large bar chart illustrates total certificate by roof description. This visualization helps us to understand the variety of roofs construction with the number of certificates in Manchester based on the different property types. On the right side, there is a map showing the distribution of average CO2 emissions by property type across the Manchester area. You can see the concentration of properties around central Manchester, with different colors represent different property types. Below that, there is a line graph showing the number of lodgements over time from 2010 to 2025. There is a notable peak around 2009, and you can see how different properties contribute to the overall trend. At the bottom right, there's a tree map displays count of certificate by genre. So owner-occupied properties have the highest number of certificate with 104,178, followed by both private and social rental properties based on the overall property types. This helps us to understand the ownership structure of the Manchester's housing. The cost page focuses on the financial aspect of energy consumption. At the top, we have 3 filter options for genre, year, and property type, allowing us to drill down into specific segments. These two graphs demonstrate the average heating cost per year is £570.45. Average total cost per year is £803.92. As you can see, heating cost is the most impactful cost type. The pie chart breaks down the average total cost distribution, confirming what we saw earlier. Heating cost 71%, lighting cost 9%, and hot water cost 20%. The middle chart shows the total lighting cost over time from 2006 to 2025. There is a significant peak around 2009, reaching approximately £3 million. This spike occurs because the number of EPC lodgement was particularly high in that year, which increased the total lighting cost shown in the chart. At the bottom, the line chart compares the current energy cost with the potential cost over time. The current cost line remains consistently higher than the potential cost line, indicating the energy efficiency improvements could be lead to cost saving over the years. On the right, there's a bar chart showing some of heating costs by walls description. Cavity walls with insulation show the highest total heating cost at around 70 to 80 million pounds, followed by solid bricks wall. This reflects both the prevalence of these walls type and their energy performance. The energy efficiency page focuses on analyzing the environment and energy performance of properties. At the top of the page, there are buttons so you can filter the analysis by property type. So you can see average CO2 emission is 3.18 in tons per year. Average energy consumption is 241.59 in kilowatt hours per square meter. These are the current values. Starting with this waterfall chart shows how different property types contribute to total CO2 emissions. Houses and flats dominate overall emissions mainly due to their higher energy usage and large share of properties. On the top right, the stack bar chart shows how energy performance ratings have changed from 2006 to 2025. Over time, there is a clear shift away from lower E, F, and G ratings, with the growing proportion of properties now achieving B and C ratings. This reflects improvements in building standards, energy regulations, and retrofitting efforts. Below that, the line chart illustrates energy consumption per square meter over years, segmented by property type across all categories. There is a clean downward trend indicating improving energy efficiency over time. Average consumption has reduced significantly, falling from approximately 350 to 400 kilowatt hours per square meter to around 150 to 200 kilowatt hours per square meter in recent years. The middle chart displays the number of lodgements by energy rating. C-rated properties are the largest group with around 0.2 million certificates, followed by B and D ratings, showing that most properties sit in the mid-range of energy efficiency. Finally, the bottom right chart compares average CO2 emissions with the environmental impact. While the environmental impact score remains relatively stable, CO2 emissions fluctuate at higher levels, highlighting an inverse relationship and the need for continued monitoring and improvements. Our final page focuses on recommendations for improving energy performance. Again, you can filter by property type at the top. All the information in this page comes after implementing the recommended measures. Here are the key metrics. Average CO2 emission 2.02 in tons per year. Average energy consumption 159.86 kilowatt hours per square meter. This clustered column chart shows total annual cost saving over time from 2006 to 2025. There is a dramatic spike around 2017, reaching nearly 8 to 9 million pounds in potential savings, with the recommendation increasing significantly during that period. The chart breaks down savings by lighting, hot water, and heating costs. This chart highlights the most frequent energy efficiency recommendations. Solar panels, solar water heatings, and low energy lighting measures are the most common, followed by insulation and heating upgrades. The color coding shows how these recommendations differ across the property types. The top right chart compares average CO2 emissions and environmental impact for potential improvements. Both lines trend together, showing that CO2 emissions increase, the environmental impact ratings decreases. The bar chart shows number of lodgements within each energy rate for potential ratings. Most properties could achieve B or C ratings with recommended improvements higher than A and D ratings. Also, B rating is reaching nearly 500,000 potential certifications. Overall, this dashboard supports decision making for policymakers and home owners and contributes to Manchester's long-term energy efficiency and carbon reduction goals. Thank you for watching.